we're now going to go ahead and take a look at how to apply these ideas of the empirical rule and normal probability distributions. But we're going to use technology. The ARTISTAT is outlined here to help us find probabilities, find boundaries, um, and connect that to what we've been studying. Now, I want to make a note. Z-tables are a common way. So in your note sheets, there's a link to these video examples of people using Z-tables to calculate probabilities. That's kind of the old school way, but some people still do that. So when you're searching, you may see that, okay? That process. We're not doing it, but if you do it, let me know. Or so when I see that in mathematics, I know you're doing something different with that. But here's an example. Personal computer, right, is used for office work at home, research, communication, so forth. Okay. Suppose the average number of hours a household computer is used is for 2 hours a day. That's the average, with a standard deviation of 0.5. And again, those values are obtained through statistical data collection. You're asking people questions, survey. Maybe they're being monitored, tracking system, right? But we know that when we put all the data together, the average is 2. The standard deviation is the half. So what's powerful is that once we have this distribution, right, we have this normal distribution, the mean is 2, and then you have that standard deviation, right? We can then answer questions around something like, what's the probability that a computer is used between 1.8 and 2.75 hours? Now, this question is different, and notice the calculations, because it doesn't fall on one of your standard deviations, right? Meaning that when we think about the distribution, how we've done in the past, you draw the normal curve, mean, and you count standard deviations. So in real world, not everything is on a standard deviation, right? It could be off with some z-score of 1.3, 1.75, negative 2.22. So that's why the calculator becomes important to do. So we're trying to find the probability between 1.8 and 2.75. Here we're asking a question, find the maximum hours that the bottom quartile is quarter, so that's the 25th percentile. So now we can solve percentile problems using the calculator. And so what you would see, the normal distribution, the mean's 2, standard deviation 0.5, and I'm looking for the x value. Remember, the x value that separates the bottom 25 here with the upper 75, and that's what the 25th percentile is. So for this problem, we go back to the ARTISTAT. I use normal distribution, so I have the web apps open. We had the mean of 2, and so we're going to calculate probabilities versus quartiles, which we'll do in the second case. And so what we have here is the mean of 2. You enter that in. Standard deviation is 0.5. That goes there. And I wanted the probability that that value was between. So we're going to do, instead of lower tail or upper tail, we're going to do an interval. And then we want that between 1.8 and 2.75. And it's that easy. So we don't need these complex z tables and stuff. And then we got the probability here. So that's where that number came from. Now, the second question, right, and again, before we go to that second question, I love how the visual, it gives you the probability notation, mean, standard deviation, and then the shaded part represents the population of people. In this case, the computers, right, the amount of hours, and it's 58% of people use a computer that between this hour, 1.8 and 2.75. Now, the other problem we were asking for quartile, the same mean and standard deviation, lower, and we just put 25 because we want the bottom 25, and that's it. We're done. And then that's where that 1.663 comes up. You now have the 25th percentile. It's that easy and straightforward. So now looking at this class challenge problem at the end, you should be able to use the normal distribution calculator to get these values. That's where they come from. There's no hand calculations here. So percentage, right, women. So again, looking at this probability, proportion, percentage, meeting the height requirement. We have the mean and standard deviation, right, of women. And we want to know the probability because the height requirement is between 62 and 78. You would enter those in and you'd get those values. So you want to make sure that you could you know how to plug those values in and you should be able to reproduce these answers here. Probability of selecting a man who does not meet the requirements, so do not means that they have to be less than 62 and greater than 78. And so you do that in two separate calculations. And again, we're using the standard normal calculator to get these numbers, and that's what you want to check to see if you can do. And then on this answer here, right? Oh, before I do that, there's another way to get this 11% or 0.11 is we can use the complement. To find the not, you can break it up, or find the percent that do meet the requirements, and then you do 1 minus. So that would be the 62 is less than x is between 60 and 78. Get that answer, which is 0.9989, and subtract 1. And that's another way using complement. And then here's again another example of the low birth weight question here. Looking at these numbers, you know 5.5, 7.5, probability less than 5.5. You can get that answer by plugging these in. Sorry, there's your standard deviation, and then plugging those in. Now, when we're thinking of on the third one of the z-scores, standard normal probability distribution, right? Find the z-score, so that just means mean 0, standard deviation 1, when we talk about the standard normal distribution, at the cutoff score of the highest 5%. So we're really looking for, in this case, the 95th percentile. The probability that x is greater than what value gives you 0.05. So we're really looking for the 95th percentile. So it's worth doing it here once, because this is probably the most challenging question. 1, 0, standard deviation there. I'm finding a quartile or percentile. I want the upper percentile, 5%. And so we got standard deviation mean 1, mean 0. I have it totally backwards. Standard deviation 1. There we go. And then you get your 1.645, which matched up to my note sheets. And then find the z-scores that cut off the farthest 5% of the normal population. So in this case, I want the farthest 5%. So this is two-tailed. So I want the 95% in the middle. And that's where I get the 1.96, because the leftover is the 5%. So I want 95% in the middle, 5% on the outside. So that's 2.5 on each side. That's where you see those numbers. And you get 1.96 and negative 1.96. And that matches up to what we have here with these values. And these are the percentile questions. So make sure to review that and know how to answer questions like that.